Okay. Questions?
About the current part of assignment 5,
Yeah.
due Thursday.
Yeah. But that, yeah.
So if I have
Just a few lines of code.
2 different threads.
Really? Just like 5 or 6 lines of code, I think.
If I have 2 different threads, can they both register and wait for a message from the same sender?
So yeah, you had a question on Piazza along those lines, right?
Yeah. And you
So what do you think happens in sockets? If 2 threads read from the same socket, what do you think happens?
One of them gets it and the next one doesn't.
So what do you think happens? I mean, can you think of a classic problem that we can reduce this all to? You know, we systems guys try to think that, we think that we have our own concepts also. Everything is not an NP issue. Well, basic. What is the first problem you learn in synchronization?
Oh yeah.
So what do we have? 2 consumers. Which one gets it? The first consumer, who unlucky or lucky consumer, depending on whether they have to do work or not.
So the question there is, do I kick out the second consumer?
No, another thing.
The second consumer receives the next message.
Yeah, that's their problem.
Okay.
Why did they go and have multiple threads? They must know what they're doing.
But I'm capable of sending the same message to both consumers.
But they don't want that. They want to alternate, right? This is not a broadcast thing.
Yeah, exactly. So that's exactly my issue. Is it supposed to be a broadcast?
No, it's just a producer-consumer problem, and you can just use the queue that I told you to go, and don't have to think about it. You're thinking too much about it. The queue will automatically go in and queue. There's a queue so I'm just saying, keep a queue, and just do the producer-consumer problem, and you guys don't even have to code the producer-consumer problem, the synchronization, because there is some Java class that does it for you, that keeps you in a queue. So. I told you guys in that. Yeah. No, I don't. This is not something that I'm going to test you guys on how good you're Googling, searching. So I'd rather do these stupid works myself and tell you about them. So I've told you exactly what to use, which methods to look at in. Now, there are some methods in Gypsy that, I just say look at them. They're very small methods. It's very hard. They're uncommented, I believe, but they might be commented by accident. Sorry? Okay, like I said, if they are commented, it's not my intention. It's like Sanjoy, whenever he gives a talk, he says, anything I talk about here, if it has any practical value, that was not my intention. And so anyway, so just use that. And so this is an issue that arises even anytime we have explicit receive. And this is different from the way we've been doing in Gypsy, where all the receivers get it, right? So that in that sense, it's counterintuitive, and that's a nicer interface. But you just give it to the first one. Okay, other things? Was it hard? Have you tried it? Have you tried the first part? It's easy, right?
We've got conceptually working.
Yeah. It's something I ask you guys to do in about 10 minutes in the exam. So it'll take you a few more minutes in an actual implementation. But that's basically it. Okay. For the next part, I don't know how far we'll get today. I don't guarantee I'll even get to it before your due date. But again, I tell you enough about it that you can understand it. And some of you who've had to go in, who didn't worry about the size being sent, have had to go through and step through some of the things that I'm going to talk about. And so you've already understood on your own some of the things I will talk about in RPC. Okay, here's where we left off. We haven't finished serialization. Serialization was a long assignment. I'll weight proportionately, both when I graded and also in the exam. Okay, because we spent a lot of time on it. And we haven't finished. So this is where we ended. We were saying, okay, we know how to do serialization in RMI. We know how to use it at least. We know somewhat how it's implemented. We looked at the Gypsy implementation. Based on that, we know somewhat how RMI implements things and how things are different. So we compared them both, and then we said, let's be more ambitious. Let's try to do serialization between different languages, which is what people do today. So and how do we do that? And we saw that, look, if you have one language here, another language there, there's no common, reflection API that you can assume. And so we will go and have an intermediate description language. that just describes the structure of what you're sending. So essentially, you guys have hard-coded a format that both sides have to agree on, and some of you allow some flexibility and say, look, this is the factory I use to serialize, so use the same factory at the other end. So you've also you've encoded a little bit about how things are encoded, okay? And you need to encode a little bit more and say, look, this is the structure that I'm sending, and this schema is understood by both systems, and you have this intermediate language. That means you have to take your data structure here, convert that into a data structure in this format, send it across, take this data structure, convert it into another language, and so you have this translation cost. Okay? And that's kind of what and what would be inside here, I said, look, we need something that has structured data. I can just take C and try to define it that way. And then later, just in the next few slides, I'll tell you why C is not really a good idea. But we can take C, or we can take XML or JSON, something that's structured types, and encode it there. And so then you have to write these translation routines. And how painful do you think it is to go and write these translation things that you convert from a data structure in one language to a data structure in another language? You don't have to do it for every application. Sorry?
It's not very painful to use something like CHAR. They usually have capability for you. It's another method of serialization.
So you're saying that
it looks like a deserialize and serialize operation.
So can you does every application programmer have to do something?
But sounds like someone else has just implemented the hard part for you.
Yeah, that's exactly.
Okay. I imagine implementing that was fairly painful.
Probably.
Okay.
Yeah, I mean, for a lot of languages, you've got the primitive types.
Okay,
Some
so
way of doing it.
you can send primitive types automatically. You can send what else automatically along on these languages?
Usually an array.
Array, okay, that's a basic type that it knows about. Maybe lists, strings,
Yes,
what else?
string type.
Any programmer-defined type you can send?
Well, as long as it's made up of the
As long as
types.
it's made up of predefined types.
Yeah.
What do you mean made up? How do we define made
Like,
up
if you
of
have
a...
a map that the key and the value pairs are both, they can be disparate primitive types, but as long as they are both primitive types. Then we
So
can
there's
make
primitive type, there's predefined types. I buy that.
Yeah.
Programmer-defined types?
I mean, you can serialize the algebraic data types, the programmer-defined types.
How? I mean, if I define a stack again, how do we serialize it?
Well, in XML, if you have a person, it'll do the tag name will be person, and then the tags within it will be first name, last name.
Okay, but that's my ADT. So how am I serializing my ADT?
You just put the class.
Abstract data type.
Top level tag.
Oh, you guys haven't heard the term ADT?
I did.
Abstract data type. Okay. Rather than
Algebraic data.
no abstract data type. That's the object type. Okay. Encapsulated object
The
type.
abstract data type is obviously composed of other.
Obviously,
No, it's
the word obviously is obviously a wrong word to use always. Never say obviously clearly. That's hand waving.
it has fields that are composed of other entities, right?
So if you look at the physical structure, we can do that. So
Or
then,
it has properties that are entities.
so we have to go and assume some. Okay, so then we have to assume some patterns. So need to do translate between language and schema representation, and automatic translation. If you're doing logical structures for beans, you can do it. Otherwise, you're kind of stuck. You have to, so there's an issue, or you can go into these variables. If you go into variables, you don't know how to go and translate it back, typically into the other side's variables, because.
It's not a map from a string to a value.
Yeah, but when you go into different languages, you can't assume the same fields and so forth. So all these systems that I'm familiar with allow you to go and send lists in that language and beans and primitive types, nothing else. They will all send logical structure, not physical structure, because to assume that both ends have the same physical structure is a little too much.
This is talking about just getting their data across, not any of the method definitions or anything.
Okay, so that's the other thing one go to. So when we're getting the data across, we're just assuming that both sides have the right type. Okay? And we just want to send the data across because you guys have just sent data, right? That's all you've done. Okay? So, so automatic translation for language-independent patterns such as beans and language-independent. Maps, they don't have any pattern. I mean, I defined a pattern. If they use that pattern, they could do it. But they will just say, use the use the map given by the language. Okay, so just use the map interface here, assume it goes and maps to the...
No, but I can't send a map. You said lists means and primitive data types. You never send
No, predefined. See, let's not confuse primitive with... So there's primitive types, there's predefined types.
or
As long as the C# predefined type can somehow map to the Java thing, and there's an IDL there, we can go and send across. Okay, but the right way to do it is to actually... I don't know why none of these people have done it, and I wish they would, because then I wouldn't have to go and tell you guys a pattern that's not standard. But they really need a map pattern and a list pattern of the kind that you guys did in your assignment. Okay? So again, I'm kind of motivating that stuff, and I'm also telling you how things work. That yes, you don't have to write your own serializer as long as you have these types. But for your own types, they will tell you how to go and extend that serializer so that you can serialize types that are not understood. Okay? And those serializers are a pain to write, because then every time you change your type, you have to go and change the representation. You have to change the translation also. Okay, so writing it the first time is easy. Keeping them up to date is always the tricky part.
Can you do versioning?
You can do versioning, but that just allows you to have multiple. You still have to, for every version, create that, right? So.
That's like how web APIs are. If the web API changes, you do like myapi.com/v1/v2, and then you hit it at that point. And normally it'll be like some different JSON or XML representation, like depending on what they change that version.
Yeah, but so they're doing a harder problem. They want to keep the old versions around.
Right.
Even when you want to just migrate from one version to the other, you've got to change both ends, and it's somewhat of a nightmare, I think.
Yeah.
Okay. So, but the IDL was something that was invented. It was the Topless paper. Topless is this transactional programming languages and systems. It's sort of the premier programming language journal, and there was a big deal when it came up. Okay. So, you know how to do Java. You know how to do Java to C#. How many of you, by the way, don't know C? Okay, so you're the one who's excused now. Because I'm going to ask some C questions. How do we go and serialize C now? You think you can serialize C? You serialize Java, you can serialize C?
I don't think that's true, no.
no, you're not serious.
Because there's no class objects that are nice and like, oh, here's my
Here's a
name,
pointer.
here's all
It
of my...
points to something.
Okay, no, if you were willing to, if you're C programmer, you pride on doing more work than necessary. So, that's okay. You're one of those. Can you even do it?
Yeah, you can do it.
I think you get it.
Okay.
You
It's
said
not
how you
exactly.
do it.
You
That was
have
the
a
question.
pointer.
Can
Here's
you
a
do it?
pointer
This
to a
is the
string.
proverbial
How long
case.
is that string? You don't know.
How would you see? Okay, so Asad is getting
knows
the.
how long it is.
What?
That string knows how long it is. It's null terminated.
It's not the terminator. No, there are things that can go wrong.
Well, there's always
Well,
things that
that's-
can go wrong.
Hang on.
Programming in C.
You're programming in C. What does cat starts S really mean?
Just
Address,
It's an address of a
memory.
character. So you guys are talking about strings. Where do strings come from? This is a pointer to a character.
Well, it's an array of characters. Which
Hang on. It's a character. I'm hearing three different answers here. It's a pointer to a character. It's a string. It's an array.
it's a
If
pointer to
you
a
ask-
character. There's
you
no
ask them
guarantee
where
that it's
the-
only one character.
Sorry?
There's no guarantee that it's only one
But
character.
Exactly.
It would
That's
be,
exactly it. This could be a
it would be
pointer to a
pointer
single
pointer.
character, or it could be a pointer to an array of characters. We
Right.
don't know.
And they're exactly the same in C. And it's a nightmare.
Okay. So if you are a programmer who enjoys such thrills, you can circumvent all of this stuff. Because you can cast it the right way. You just know what it is. You don't have to have Java keep track of that. You've got active gray cells here. And so you go and keep track of all of this. But when you give it to the serializer, it's all in your head, right? What is the post serializer going to do? It's got to go and send either one character or 10 characters or whatever. So, it's interesting that there was all this C-based programming and they didn't have a distributed C. Ever. So I'll tell you how that came about. I did it, and I'll tell you how I did it. But this is the problem. Okay, and is it Is it, so, this is what it typically will be. You guys all jumped on it being a string, which is, and, you can say it's a bunch of characters. Or you can say it is what is declared to be a character, right?
I mean, that's rarely what we actually say it is.
And so we say, oh, it's strong typing, who cares about it? When you're doing distributed computing, strong typing matters. It can be dynamic typing. It doesn't have to be that you have to, it can be Python, where the type checking is only done at runtime. But it has to be typed. There has to be unambiguous type for it. Okay? So weak typing, and you guys know about this?
I just read about it in my C for Dummies book the other day.
Yes.
Which is, it doesn't make any sense.
Do you know?
Bit packing.
It is subclassing.
It's two different types, right?
So what does happen?
You have to keep a separate
So when I
variable
create-
which type it is.
Okay, that's good. Okay?
That's terrible.
But how do you think objects got invented? That is this is the precursor to subclassing, that this is a common type that both of these things are derived from, and that type, the memory representation is either this or this, and they can be treated as one type. That's like having class object be the common type for the two different things.
Well, I'm sorry, but how is this like subclassing?
Because
it can be either.
it's either this type or this type. It's not both.
So you can make a pointer
have
to one
an
of those
integer,
things,
or
and
you
you've
can
got
have
no
an array
guarantee.
of 4 characters.
Okay. So this is your so it's unions create. I mean, I'm just telling you all the joy, the joys of using C.
Why does everyone use this thing?
I mean, don't even get me on this thing.
I actually know.
Because, I mean, it's okay to use this language when alternatives didn't exist. Okay, excused. What is really inexcusable about this country, not Europe, Europe got it right, is that, since Mesa got invented and all these nice languages got invented in Xerox, till Java got invented, this place was doing C. And Europe was going to modular, Europe was going to other languages, but, this country said, we guys know what we're talking about it. If it wasn't for web, Java wouldn't have been popular. If Java had been popular, we would be still dealing with this stuff in the context of C++. Okay, C++ is still, it added some sense to this whole language. And that's why when people worship the Kernighan and Ritchie book, I don't know what they're talking about. Fine, it was fine to worship it, 30 years ago. But to worship it now just makes no sense, So C for Dummies, if you're reading, I don't know. C, right now, C.
Yeah, it's like the thing, there's no Boolean type, which I knew that.
No, but that's one of the, okay, so that's the thing. That's one of the less excusable. I mean, you guys would have liked it better because you would have had written one serializer, and the programmer would have gone and converted that into true or false, and you wouldn't have had to send 0 or 1, right? Or true and false.
It's a programming language of choice for low level.
Yeah, absolutely. So that's where Mesa is a language that said you can do these things. So you can basically, the advantage here is that I can take the int and I can treat it as bits or I can treat it as characters. So as an operating system person, this is great, and you really need to do this. But what Mesa did was it said, look, if you can always break typing if you want to, but you'll have to do some extra work to do so. And whereas Java said, C said if you want typing, you have to do some extra work. Okay, but be that. I mean, and when I was at Microsoft, they really tried to ban C completely. And I was sitting with the OS group, and rightly so, the kernel group protested, and they were able to go and still code in C. So.
I think the bigger question is, if the kernel wasn't written in C, would C be as big a language as it is for a program?
Yeah. So, anyway, so this is just telling you, why I do many interpretations, and. So what do we do? If we want two C programs to go and communicate and send serialized data, what should we do?
You should have one include file that contains the respective.
No, fine. Even with the include file, that the include file's got CHAR. Absolutely. You have to have the same include file.
That's your idea. That include file is then your idea.
So then you need an IDL that's separate from C. Because C is not strongly typed. So what you do is say, let's come up with a strongly typed IDL and let the C programmer who loves to program now also go and convert his data structure into an IDL and convert it back. And so, I'm just saying that, so give up on. So this is where IDLs came about, and there was an IDL called, so this is the problem, and there was an IDL called Korba. Okay, so Korba became very popular in the late 80s, and people said, and it was meant to allow different languages to talk to each other, but there was only one language, C, really. So what were they really doing? They were making C programs talk to each other. Okay, and it had all these issues, and I had to go and create distributed systems, and I didn't want to go and convert to Korba and keep updating the data structure. Each time I change my include file in C, I had to go and write a translator. So I did quote the hacky way, or the proper way. So I said cat star S, of course it's going to be a string. Okay, and if it's not, serves you right. Not quite. Not quite, because I was doing it for myself. Okay, that's the default. And what I said was, if you've got this union here, and I did have unions like this, we assume that the previous value is a tag, and I will use that tag value to discriminate between these. Okay, and you can go and put a little. These were these. So I had a precompiler that would go and precompile C programs to generate the stubs. Okay, so what I shouldn't say I. This was my first student. He was a master's student, probably the brightest student I've ever worked with, Eric Vaslik. And he designed this whole thing and implemented it. And he had his object compiler, and you just go and add an annotation saying how it is to be interpreted. It's got 3 or 4 interpretations. So I don't believe anybody else has written a distributed C thing, and I guess people just moved on. But this is something I didn't want to program in C, but that was the language of choice everywhere. So that's how I was able to work. Okay. So these annotations can be used to type things. Okay, so Ian isn't here today, and otherwise he would have enjoyed this part more, because we introduced it last time and he had a lot of questions on it. So let's make the problem even harder now. So we said, okay, if one language, the types exist at both ends. Different languages, the types exist at both ends. Now the type exists at this end, but it doesn't exist at the other end. And the question I posed last time, which is where Ian got involved, was, does it even make sense to serialize something and send it to the other site if that site does not have its type? If that program that's receiving it has no knowledge of that type.
Well, at this point, do you care about the other side if you're just serializing to an intermediate language?
Well, yeah, of course you care about the other side, because if you put in some IDL form, then if the person you want to read it can't read it, then you waste a lot of time.
They're writing a deserializer. For
No. That's not what I'm trying to say. That, okay, different languages is one issue. Let's go back to one language for now.
Okay.
There are 2 dimensions here. Same language, different language. Okay, that's one dimension. Known type, unknown type. So we have 4 combinations here.
Okay.
Okay, so let's assume we are working in Java, completely in Java.
Okay.
I'm a Java client. I'm sending the Java from my program. I'm sending a serialized object to another Java program. That Java program does not have my type in its class path. It doesn't have that type anywhere in its program. Okay,
I was
so
about to say, can we come up with some way of sending the information that encodes like how the type works?
okay. Firstly, if we could, let's assume we could. Okay, we could just send the class file.
Right.
Okay.
That's
What is it?
incredibly dangerous.
You can then
So I got to tell you guys. Sorry.
Yeah.
That's
This is really dangerous to send a class file across the wire like that.
So you could send a link to a class file.
Clearly you have not enjoyed the dangers of C. So you find this to be dangerous,
Yeah, I'm learning it since I have to learn it. I don't think it's a good idea to program.
Oh, I think so. When when Java was first invented, I ran into somebody who had done the distributed part of Java, and of course, everybody was saying at that time, "What's so new about Java?" Right? We'd all seen these things before. So I said, "Oh, what's so new about Java's distributed thing?" I did C-based RPC before you did Java-based with strong typing. I'm a better man than you. And his answer was the following: no other language allows classes to be sent, allows some object to be an object to be sent of a type that doesn't exist at the other end. Actually, I haven't found out a way. I never, I keep sending. I should send a mail actually. I haven't seen how Java does that exactly. But assuming it did it, okay, that was a feature he was really proud of. Okay.
You can send the bytecode across. But
No, but Java's serialization doesn't do it as far as I know it. Doesn't do it automatically. Okay.
No, do you have to do it on?
Yeah, right. We'll talk about that, right? But the question is, even if he could do it, why is that useful? Let's say I can send the class across. I mean, that program doesn't know anything about the type. Why are you sending it a type of object that the writer had no knowledge of? How could it use anything to do with the type?
Well, maybe it's a different implementation of a type that it does know about.
Okay.
It has, like, it approaches the problem from a different way, but still provides the same information.
So maybe the interface it knows?
Right. The interface it knows, but...
And it can use that interface and just a factory returns this object?
Exactly. Like, the underlying implementation is different, so it has different fields and variables and all that sort of stuff that it needs to deal with, but it still returns something that is useful to the program.
Okay. And when Java came about, what did I say was the first selling point of Java that really made Java? Garbage collection existed a long time. Yeah, I mean that. No, but garbage collection is for people who were not for real programmers, right? I mean,
I love garbage.
you want malloc and and
You
dialog.
want malloc and free. Come on.
Yeah, you want malloc and free.
Strong typing and garbage collection.
No, why did Java take off?
Interfaces.
No, interfaces existed in a better form in other languages.
Haven't used them.
You guys are all JavaScript guys. Before there was JavaScript, what was there? Yeah, HTML, very, very boring HTML. How did you make it interesting? How did you do dynamic things? How did you do?
CSS.
You guys haven't even heard of applets?
Yes.
Yeah, but
applets are a
I
Java
thought
thing.
Java
Applets are Java.
Yeah.
Yeah,
They came out
that
after
was never
Java.
a good idea.
And
So
when
Apple-
That was their selling point?
Absolutely. Absolutely. Those pages became alive. Those web pages became alive. Not the stupid forms, but you could have animations.
Applets were the first thing trying to do that.
Absolutely.
Did Flash come before applets or not?
I've never followed Flash. At some point, Flash became something I had to take note of. So it was never something interesting in my head. So, but
the first web games that came out, like
it was all.
they were Macromedia, Flash, and Shockwave. They were Shockwave.
I'm telling you, the first time on web pages you saw activity was applets. Okay.
I didn't know that was. I mean, I was aware of applets.
That was it. That was absolutely. That was the only reason to use Java at that time. Okay. And so, can you relate applets to what we are talking about?
Applets classes understand. Applets get their code from the server and they run them locally.
And what does the browser do? It goes and invokes the init method in the applet. That's like invoking that interface method. Okay. So.
Applets are written with security flaws because you can download bad applets and run them, and there's no check.
But that's why there's sandbox. There's sandbox. Yeah. Okay. So receiver doesn't know about the sent values, and actually, even we don't even have to send the class across. We talked about this last time. I can just send the byte array, and if it's a relayer, it can go and send the byte array to somebody else who has the type, and it's just a storer, along with the size field. Okay, it will go and send that byte array across, and that guy can go and decode it. Because we are doing this byte array based thing and not this byte stream based thing, and because we're not doing any compression, we can have a logger, we can do many things here that you can do.
Just a question, you mentioned that, okay, so I get the point that it will be there as to knowing how much to read. But when returning the byte buffer, why didn't you just peel off the info?
Ha ha ha, why didn't I do it? If you were keeping it, focusing, there was this big debate we had in class that time. And Ian said, which way did you go? And I said, I don't know which way I went. But if I peeled it off, what would I be doing? If I've got 40,000 bytes there, what would I be doing?
Peeling off just 4 bytes.
And copying it?
Oh.
You guys didn't care about copying. You just created mallocs, You want to create and deallocate, right? Like Roosevelt said, dig holes and fill them up and keep you employed. I mean, why do you want to do that? Okay. So that's what I do, and you better not, munge around and write things in there because that's a system buffer. That's the NIO buffer. I'm just keeping one buffer, and I give it to you guys. I keep track of the pointers. If you go and read in there, I'll keep track of my old pointers, but you better not mess around with the data. And that's fine, right? Because what are you going to do? You're going to take those bytes and copy them into an array or into a string. So you have no use for that buffer after you copied it into the actual object. So why should we create an extra copy? Okay. So so we can go how to support. So now yeah, I've got some spelling here. So in one case, the type, and so what do? This is what I'm saying here. That it can just store it, or it can just not even have the type sent, and it just goes across, and so it's either stored or it's sent somewhere else. So that's what I'm saying here in these slides. And that's actually, I really, okay. So if no handling, so either the other side is handling it, or just not handling it. By handling, I mean it's processing it. Okay, and so processing requires us to. I'm just saying this is what you can do with Gypsy. What can you do now? You can invoke some method of known supertype. Interface. You can go and applet thread start method, and the supertype could be an interface or a super class. Okay, that's what I'm saying. If you're going to actually handle, this is what you're going to do. And here's something I dreamed up. You can do reflection always, right? So if I'm a grading program and the students have submitted their classes, I don't know their classes. I'm going to just reflect on them and see various aspects of them. Okay, and that's exactly what we are doing for a while. Here's something. What do you think of this idea? So I'm a client, and my computer is not powerful. So what I do is I go and send you this object, and then I invoke methods on it. And you just go and through reflection. Ultimately, when you're invoking methods at the other end, you're doing reflection. Okay, so you are just invoking methods that you don't even know anything about.
I feel like that's a recipe for disaster.
Why? You can't be so scared.
Dude, sandboxes are perfect. You never get
It's
outside
just a
of them.
tool, like power source can do.
I don't know whether you guys listen to TED Talks or Radio Lab. One of these two things talk about, it's either, I think it's something that enters a cockroach and it just goes and puts all of its genes into the cockroach, and it just rides the cockroach and makes the cockroach do whatever it wants to do. So there's this parasite, or there's this.
Oh yeah, it's a worm and it makes it brown.
Okay. So it's this worm that just goes and implants its whole DNA or whatever into that guy, and so that's what this is happening here. So the client is just going and invoking methods.
I didn't do that.
So this is
But like, how would you? You just go and invoke every method on a class. Like, if you don't know anything.
No. I'm the client.
No. So like he's saying, like, you get the method put over, and then I'm the client. I put the class on this really powerful computer, and then I'm going to call a method on it, which it will execute for me via reflection, and then give me the return method.
Oh, okay. I was thinking like you just didn't know anything, and you just said, all right, I'm going to go through every single method, and I'm just going to call A, call B.
You
No.
want arguments.
Yeah, that's what I'm saying. Like, at some point, you have to have some knowledge, either in band or out of band, because like if you write the program that calls the methods, like
No, but you
some
can.
kind of expectation.
Yeah, there's some expectation, even reflection, right? So
Right. Okay.
so anyway. So and then applets. You can imagine that your RPC mechanism, when it sends the applet, it's sending the applet class along also. And I really thought I listened, this guy Waldo, I remember this guy's name also. Waldo was this guy in Sun. And he said this is what happens, but this is not exactly what happens. So applets, and you have to use a class loader. So what you end up sending a link, and forget this code, this is just some code to do it, that you actually send some URL, and that URL can be used by the other end to go and fetch the class. Okay, but it would be nice to do this.
Like Java's big selling point was as a client-side framework, and now you use Java to generate web pages. Like it's totally.
It's now a server. Oh yeah, applets were the reason. And all these, what also happened was that all these teachers, I mean, I never taught applets in my Java class, but all the universities loved the fact that you could do graphics very easily. You just go and override the init method and the paint method in the applet, and you just went and said graphics.drawLine, graphics.square. So you just have to tell people, this is all magic here, applet, inheritance, etc. Just go and override this method, and then you can do the graphics. Okay? So that was the big deal. That's why a lot of academics like it. And of course, I went to Java, and I'm the one who sort of moved people into Java from functional languages, not from C or Pascal, from Pascal also actually, just because strong tactic. And if you're a teacher, I mean, you guys come to me and I said, okay, come to me after office and I'll help you debug. Just imagine when I taught operating systems and they had to write this whole threads package and synchronization package and RPC package in C. I don't want to go and deal with their core dumps, right? And I didn't. I said, hey, go to the T. Not because, because I've got other interesting things to do, because I can't do it. So.
There's another thing I don't miss from C is seg faults.
Absolutely, core dumps. I mean, that's yeah. Okay. About URL set. And now we go to the other dimension, that unknown type and different language. Yeah, let's just give up our hands and say. Rob's is going to be even more concerned.
Well, like the way I'm conceiving of this is, say there's some language and it doesn't support like IEEE 754 floating points. So it gets like 32, or yeah, we'll say just float. So it gets 32 bits, but it has no way of conceiving how to understand those 32 bits as a floating point number. So like, what could you possibly do?
Okay, so by the way, you can do something here also. You just send your beans, etc., to the other side. That gets all converted into XML, and the other side just treats it as XML. And your person, employee, all these static things without any application semantics would work just fine. Okay, and people.
In this case, you do need some sort of intermediate, like
Yeah, absolutely.
some agreement about
No.
what they can possibly.
Multiple languages, schema needed.
Okay.
Clear, The schema is needed. The question is, we don't even know. We can't convert this. We convert only one way. We don't convert the other way, and we just deal with the schema language. And you can do interesting applications that way too. Okay. So it's like when I send the BMI spreadsheet, I can send the height and weight, but there's no way I can get the get BMI calculation done at the other end unless I encode that somehow also. And that's getting hard. There's a guy in Utah who for the longest time has been trying to go and do multiple languages. And it's really hard. And in fact, when I was at Purdue, there was a faculty member who tried to create a single language that captures Prolog, ML, and Smalltalk, which basically object-oriented logic programming and function and type inference. And the guy was 10 times smarter than me. But the guy just never managed to get tenure anywhere except for one university, just because it was so hard. He was the student of Greece, who was a well-known scientist in Cornell. It's just too hard a problem. Sorry?
Yeah. So that'll drive you mad.
But that's what people thought what academics are supposed to do, these hard problems, right? So you can be too smart. Okay, let's go and put this all in context. We're talking serialization. I can serialize to the file. But that's not what we really are concerned about. We're talking about serializing and sending data to another end. And of course, as you guys have seen, that you first just did serialization, deserialization, then you put it in a communication framework. And I already told you guys this before, but just to remind you that we have these buffer ports that are sending byte buffers. And every time a byte buffer is sent, the size is sent. Okay? And then there are these object ports. And in between is your serializer. And so there was this trappers that exist between ports. And these trappers can be either pure forwarders or they can be translators. And the serializer is an example of a translator. And it just converts something from an object to a byte buffer and a byte and other way around. And this is where I go and call your routine to do the task. Okay. Again, I want to also remind you, we went through this before, but just to remind you, that in fact, Gypsy is, the G could also stand for group. In fact, group was a big deal when I was communicating, when I was building the system. So I made it generalized IPC. It could be generalized group IPC. So there's group communication. So there's group type data that you can also send. You can send the same data to multiple sites. And we saw there was an issue here, if you remember. So is there any challenge here? I mean, we guys all can write a loop that goes and sends something across to multiple sites. The multicast is not hard. But was there an issue in the design of group communication, typed communication? That you guys, I talked about it.
So you run into a problem where you have to first figure out who sent you the message to begin with and then not send them. And
Okay, so that's a group semantics. Good. The others, all, etc. Right? This layer also has that are you sending it to the sender or everybody? So what about group type? So that's the issue at this layer. What about an issue at this layer? Notice that this layer is sitting on top of what layers? Byte communication, group byte communication. There is typed data communication. So this layer is sitting on top of both of them, right? It's type and it's group. So when a message goes from here to here, what paths can it take?
you can either go to group by group.
So it can either go and multicast and then serialize, or serialize and then multicast. Right? So it can either go this way. Actually, this arrow should have gone. It should have gone through type data communication. It could have gone like this also. Okay. And which way did we say it should go? So it can first multicast. It can first multicast and then serialize, or it can serialize first and then multicast. I got to redraw the arrows. I have to sort of make it go like this. We talked about it last time. Is serialization a costly operation? So we want to go?
Serialize multicast. But what if, for some reason, on different posts you need a different?
Or if you need a different value, then yes, that's there. Yeah. But right now we are multicasting. They're sending the same value across.
Well, I was thinking that maybe some machines, for some reason or other, would want to use a different deserializer.
But the point is that when you serialize, you're serializing for all machines.
Right.
Okay. But today, if you want to use Java, you'll have to go this way. Okay. And okay. Okay, and just to show you some of the layers, we have byte communication, we have object communication, which we are copying objects. Now, where will object reference come in when you're sending references to objects?
If it's recursive or something like that, where it needs to.
Okay, that's okay. I'm using the word reference overloaded here. So that's just making sure that the data structure is isomorphic. But when an object is sent to the other side, we can either go and send a copy, or we can send a replica, or we can send a proxy.
Right.
So where the proxy layer comes over this.
Well, no, you just serialize the proxy.
Okay, you serialize the proxy. So the proxy layer will come on top of this then? If you're going to serialize the proxy, then the proxy comes here, and we serialize the proxy, right?
Yes.
Anything between the object layer and the proxy layer? So there's an object referenced layer that. Sorry?
An RPC?
Right? So this is very interesting, that object communication is split into two layers, and in between is RPC.
Oh, yeah, so you could be referring to something remote, and you'd have to figure out how you're going to serialize.
So RPC is built on top of this, and object is built on top of RPC. And let me ask you guys another problem, your operating system problem. Process management, memory management. You guys know all of that, what it means? Which comes on top? Memory management is the bottom layer, or process management is the bottom layer?
Memory, yeah, because you've got your processes are stored as these nice frames. And
So when I create a process, I need stack, I need heap.
yeah.
If my malloc, since you guys enjoy malloc so much, was blocking? If I don't have memory, I block the guy till memory is available.
Wait, instead of throwing an error?
So you have low-level memory management, process management, high-level memory management. These are the joys of systems programming. Come on, I'm sure when you're in Jim Anderson's class, there's much more of this going on than in this class.
Notice I'm not in Jim Anderson's class.
You're not? Okay, that makes your head hurt more. So these are the kind of things that make systems.
It's things that I wouldn't think to do. So.
But if you're designing the point is that when you're doing layering, sometimes something that's logical has to be broken into multiple things because this layering thing doesn't work very well. So I'm just saying this sort of a system design thing. And you can imagine how much my head hurt when I built this system out of scratch, right? Because there was really no other system I could go by. So I'm just sharing with you my headaches. Okay? And this thing is called unmarshaling. When you go and take procedure calls and convert them into something serialized, that's unmarshaling. And it involves both object reference and transition into this. Okay? And this is just deserialization, serialization. So this to this is serialization. This to this is marshaling. Okay? And that's sort of where we go to next.
So marshaling just involves
Serializing a method call,
oh,
which you guys have had to deal with even though you didn't want to.
yeah, a serializable call. Is that the class?
It's a serializable call extends
magic
a remote
class.
call, which has all the other
That does
actually important
everything.
stuff inside of it, except for